Hello students, we will do one more example. So you are given a differential form y dx plus x dy plus 4 dz. Show that this is exact and evaluate the integral integral 1 to integral 2 3 minus 1 y dx plus x dy plus 4 dz. So this is not new to you because exact differential, they are in 1-to-1 correspondence with conservative vector fields. So how do I check exactness? So this is your m of x y z is y, n of x y z is x, and p of x y z is 4. So what is exactness? It is the same as saying that the corresponding vector field is conservative. So dou m by dou y, what is this? Dou m by dou y is 1, and what is dou n by dou x? That is also 1. And dou n by dou z, dou n by dou z is 0, and what is dou p by dou y? That is also 0. And dou p by dou x, dou p by dou x is 0, and what is dou m by dou z? Dou m by dou z is also equal to 0. So if these three equations hold, then the vector field is conservative, or equivalently the differential form is exact. Exact. Now I want to evaluate this integral. So how do I do that? See, if a vector field is exact, then a vector field is conservative. That means if the corresponding differential form is exact, then that differential form can be written as mi plus nj plus pk can be written as, this is vector field, not this, the differential form, m dx plus n dy plus p dz, it is equal to df for some f. Okay, so this is dou f by dou x vector I mean dx vector I dx plus dou f by dou by dy plus dou f by dou z dz. Okay, and I want to evaluate this differential form m dx plus n dy plus p dz from one point A to another point B in the space. So A and B are points in the space. This is the space. Here is the point A, and here is the point B. The corresponding, so this is integral A to B df, right? So what is this? So this is integral A to B df is this thing. So this is equal to integral, I will write dou f by dou x into dx by dt plus dou f by dou y dy by dt plus dou f by dou z dz by dt times dt. This is how you evaluate line integrals. This is a line integral. This is a line integral, and this is the corresponding Riemann integral. So t varies from where to where. So you have, so take any path from A to B. So let us say this is the path from A to B given by C. So integral a to b means integral over c. Integral a to b means integral over line integral over c. So correspondingly there is a parameterization for this path. So this is the corresponding parameter interval. T varies from a to b. Here you have the point t, here you have the point r of t, like that. So when you evaluate line integrals, you have to convert it into a Riemann sum, a Riemann integral. So t varies from a to b. So so if this map parameterization is given by r of t, vector r of t, then r of small a is capital A and r of small b is capital B. Okay. Now what is this? This is precisely I will take the next page. So this is integral t from a to b. So this is dou f by dou x, comma dou f by dou y, comma dou f by dou z, vector dot product with dx by dt, comma dy by dt, not dou y, dy by dt, comma dz by dt times dt. Right? This expression in the brackets is precisely dou f by dou x, comma dou f by dou y, comma dou f by dou z, dot product with dx by dt, comma dy by dt, comma dz by dt. And what is this? This is integral t varies from a to b. What is this? This is precisely del f. Dot, what is this? This is precisely dr by dt dt. But del f is vector f. This one. See, when you use vector fields, you will write f equal to del f, where f is mi plus nj plus pk. This is for differential forms. I mean, this is for vector fields. And when you use differential forms, how do you write? This m dx plus n dy plus p dz. That is your differential form, which is equal to, here you will write df. df means dou f by dou x vector, I mean dou f by dou x dx plus dou f by dou y dy plus dou f by dou z dz. This is for differential forms. Remember, they are the one and the same thing. This is the way physicists like to write their expression, and this is how mathematicians like. That's it. So what is this? This is precisely integral f dot dr. Work done. This is precisely integral a to b f dot dr. So why did I say this? This is because you are asked to evaluate this line integral. What is that? Yes, you are asked to evaluate this line integral, but you have observed that this differential form is exact. That means the corresponding vector field is conservative, and to evaluate f dot dr for a conservative vector field f, what you have to do, you have to get an antiderivative of that vector field or potential function. say small f, and the value of this integral is precisely the value of that potential function at the upper limit minus value of the potential function at the lower limit. So now you have to find out the potential function. The problem reduces to finding out the potential function. Okay. So so m is for the given what is the given vector field, what is the given differential, it is 7 dx plus n dy plus p dz, which is y dx plus x dy plus 4 dz which is df, because this is given, this was exact. So the x is f such that this is equal to df. So this is dou f by dou x dx plus dou f by dou y dy plus dou f by dou z dz. This f exists. So equate these two. This is also a differential form. This is also a differential form. You can equate. So you will get dou f by dou x equal to y, component wise equate. Dou f by dou y equal to x, and dou f by dou z equal to 4. Now you want a small f such that you know this exists, but you don't know what it is. So you want a function small f and whose partial derivative with respect to x is known and it is equal to y. So what is f? So from first equation implies f of x comma y comma z equal to, come on, integrate with respect to x keeping y and z constants. So y into x, y is a constant, we are integrating with respect to x, plus a constant of integration phi1, which will depend upon the y and z which we have already fixed, where phi1 has to be determined. It's the constant of integration. This technique we have already done in the previous problem. So second equation implies dou f by dou y equal to x. But f is this. So what is dou f by dou y? Dou f by dou y is, I differentiate this with respect to y, so I will get a x plus dou phi1 by dou y, which is equal to, this is my dou f by dou y from this equation, and that must be equal to x from second equation. Understand? So this I will repeat again. This is your f, and dou f by dou y from this equation you found out to be equal to x plus dou phi1 by dou y, and from the second equation that dou f by dou y must be equal to your x. So LHS is obtained by differentiating this f, which we have found out, but not completely, because f will be completely determined once phi1 is determined. Okay. Now you can cancel this x and this x, and you can write dou phi1 by dou y is 0. This implies phi1 is independent of y. Already it is independent of x. So now it depends on only on z. So let us write this as phi2 of z, where phi2 has to be determined. Okay. Now use the third equation. Third equation implies implies what is that? Dou f by dou z is equal to 4. Oh, okay. I will erase this. I will come to this. Therefore, this f of x comma y comma z, I will write it, which is equal to xy plus what is phi 1? Phi 1 is phi 2 of z. Phi 2 of z. Now let me use third equation. Third equation implies dou f by dou z is equal to 4. But what is dou f by dou z? It is phi dash z. Phi 2 dash z. Phi 2 dash z. Here partial derivative with respect to z becomes the ordinary derivative of phi 2. That is equal to 4 from this equation, third equation. This implies phi 2 of z is equal to 4z plus some constant c. Okay. So now let us substitute for phi 2 of z in this equation. So f is completely determined. Thus f of x comma y comma z equal to xy plus, thus f of x comma y comma z equal to xy plus, what is phi 2? It is 4z plus a constant. Yes, 4z plus a constant. Therefore, the line integral y dx plus x dy plus 4 dz from where to where? 1 1 1 2 2 3 minus 1. I think these are the lower and upper limits. So this is equal to, this is f dot dr, integral from a to b f dot dr, that is equal to, what is a is this 1 1 1 and b is this 2 3 minus 1 f dot dr. You can skip this if you know this. So how do I evaluate this? This is, since capital F is conservative, this is value of the antiderivative small f at the upper limit. Upper limit is 2 3 minus 1, 2 comma 3 comma minus 1 minus value of the antiderivative at the lower limit 1 comma 1 comma 1. So what is this? What is f? This one. So evaluate that f at the point 2 3 minus 1. So what you will get? 2 into 3 plus 4 into minus 1 plus constant minus f of 1 1 1 is 1 into 1 plus 4 into 1 plus c. This c and this c cancel. So what is this? 6 minus 4 minus 1 minus 4. So what is this? Minus 8 minus 9 plus 6. So minus 3. Yes. So this is how such kind of problems are being done. Thank you.